Welcome to the world of Industry 4.0 and the Smart Factory, a world that integrates the power of automation, interconnectivity, machine learning, and real-time data. Industry 4.0 represents the fourth industrial revolution, one that is reshaping the landscape of manufacturing and production. It's not merely a buzzword but a paradigm shift in how we create, distribute, and consume goods. At the heart of Industry 4.0 lies the Smart Factory, a place where machines don't just perform tasks but think for themselves. Picture a production line where machines talk to each other, diagnosing faults, optimizing processes, and predicting maintenance needs all in real time. This self-regulating ecosystem is what we call a smart factory. Now let's delve a little deeper into some key terms. The Internet of Things, or IoT, refers to the network of physical devices, vehicles, appliances, and other objects embedded with sensors and software that enables them to connect and exchange data. In the context of Industry 4.0, this means machines, products, and systems communicating with each other and with us. Next up, big data. Imagine the vast amount of information these interconnected devices generate. Big data refers to the massive volumes of structured and unstructured data that inundates a business on a day-to-day basis. It's not just about the amount of data, but what organizations do with it. Finally, cyber-physical systems. These are integrations of computation, networking, and physical processes. Embedded computers and networks monitor and control the physical processes, with feedback loops where physical processes affect computations and vice versa. So, what does all this mean for manufacturing? In essence, it's a shift from doing digital to being digital, where businesses harness the power of technology to transform operations, products, and services. As intriguing as it might sound, the future of manufacturing is here, and it's called Industry 4.0. To appreciate the marvel that is Industry 4.0, it's important to understand its evolution. The dawn of the first industrial revolution in the late 18th century marked a seminal shift in manufacturing. This era was characterized by the mechanization of production using water and steam power. It was an age where we began to harness the power of nature to fuel our ambitions, replacing manual labor with machines in various sectors, predominantly textiles. As we moved into the second industrial revolution in the late 19th century, electricity took center stage. The introduction of electrical power led to the development of assembly lines, paving the way for mass production. Products that were once painstakingly crafted by hand could now be produced en masse, drastically lowering costs and making goods accessible to the wider population. The third industrial revolution in the mid-20th century brought us into the digital age. The advent of computers and information technology revolutionized the way we managed and controlled production processes. Automation became the norm, and factories were filled with machines that could work tirelessly around the clock, increasing efficiency and productivity. And now, we stand at the precipice of the fourth industrial revolution, commonly known as Industry 4.0. This revolution is characterized by the fusion of the physical and digital worlds. It's an era where machines are no longer merely tools but intelligent systems capable of learning, adapting, and making decisions. With the incorporation of cyber-physical systems, the Internet of Things, and cloud computing, Industry 4.0 is set to redefine manufacturing once again. Just as steam power, electricity, and computers transformed the industrial landscape in their respective eras, Industry 4.0 promises to deliver unprecedented changes. It's not just about making factories more efficient or productive. It's about creating a smart, interconnected ecosystem that can respond in real time to changing demands and conditions. From steam power to cyber-physical systems, the journey has been nothing short of extraordinary. And as we delve deeper into the world of Industry 4.0, we can only anticipate what remarkable innovations the future holds. With the advent of Industry 4.0, the concept of the smart factory was born. A revolutionary idea that has reshaped the face of manufacturing as we know it. But how exactly did this come to be? The birth of the smart factory wasn't an overnight phenomenon. It was the culmination of years of technological advancements and a drive towards digitalization. As Industry 4.0 took hold, traditional factories began to evolve, embracing the power of data, connectivity, and automation. The smart factory was born out of the need for greater efficiency and productivity. At its core, it's all about harnessing real-time data, utilizing machine learning and artificial intelligence to optimize production processes. Imagine a factory where machines communicate with each other, where they can predict and resolve issues before they even occur. That's the power of a smart factory. But it's not just about machines talking to each other. A smart factory is also about people. It's about empowering workers with the information they need to make better decisions, faster. It's about creating a work environment that's safer, more efficient, and more productive, all thanks to the power of data and connectivity. Now let's delve a little deeper into how a smart factory operates. Think of it as a living, breathing organism, constantly evolving and adapting. It thrives on data, collected from every corner of the factory floor. This data is then analyzed using machine learning algorithms, providing insights that help optimize every aspect of the production process. From predicting machinery breakdowns before they happen, to optimizing energy usage and reducing waste, the possibilities are endless. And it's all done in real time, allowing for immediate action and continuous improvement. The smart factory is more than just a concept. It's a reality that's transforming industries around the world. It's about creating a symbiotic relationship between man and machine, where each complements the other, leading to greater efficiencies and a more sustainable future. And so, the smart factory is a testament to the power of data and connectivity in the modern industrial age. It's the epitome of Industry 4.0, a beacon of what's possible when we harness the power of technology to drive progress. Now that we know what Industry 4.0 and the smart factory are, let's delve into their key elements. The first key element of Industry 4.0 and the smart factory is the Internet of Things, or IoT. This is essentially a network of devices, vehicles, and home appliances that contain electronics, software, sensors, actuators, and connectivity, which allows these things to connect, interact, and exchange data. In the context of the smart factory, IoT devices provide real-time data on machine performance, product quality, and system inefficiencies, enabling immediate action to optimize production. Next up is big data. With the immense amount of information generated by IoT devices, factories need a way to process and analyze this data to extract valuable insights. Big data technologies not only handle the volume of data, but they also provide the tools to transform this data into actionable knowledge. This knowledge is then used to improve processes, increase efficiency, and ultimately, enhance profitability. The third element, cyber-physical systems, or CPS, is the backbone of the smart factory. These are integrations of computation, networking, and physical processes. Embedded computers and networks monitor and control the physical processes, with feedback loops where physical processes affect computations and vice versa. In simpler terms, CPS are the systems that allow physical and digital components to interact seamlessly. Last, but certainly not least, we have machine learning. This is a type of artificial intelligence that provides systems the ability to learn and improve from experience without being explicitly programmed. In a smart factory, machine learning algorithms can predict machine failures, optimize production schedules, and even develop new manufacturing processes. These elements, IoT, big data, cyber-physical systems, and machine learning, work together to create an efficient and automated manufacturing environment. They form a complex, interdependent system where information flows seamlessly. Decisions are data-driven, and machines can learn and adapt to changes. These elements are the building blocks of a future where machines not just perform tasks, but also make informed decisions. Industry 4.0 and the smart factory aren't just concepts for the future, they're already here. As we stand on the brink of a technological revolution that will fundamentally alter the way we live, work, and relate to one another, we're seeing the real-world applications of Industry 4.0 and the smart factory come to life. It's not about replacing human beings with machines, but about augmenting our capabilities, speeding up processes, and improving the quality of our output. The smart factory, powered by Industry 4.0, is already yielding notable benefits. Take, for instance, in manufacturing, we're seeing a significant increase in efficiency. By harnessing the power of real-time data, we're able to monitor, analyze, and optimize production processes like never before. This not only speeds up production, but also reduces the likelihood of errors, leading to a significant decrease in wastage. Furthermore, the smart factory offers greater flexibility in production. The days of one-size-fits-all manufacturing are long gone. The ability to customize products to individual customer needs, yet maintain efficiency and cost-effectiveness is no longer a pipe dream, but a reality. But let's not gloss over the challenges. The increasing reliance on digital systems brings with it the risk of cyber threats. It's a challenge that we must face head-on, with robust cybersecurity measures. And then there's the human factor. The workforce needs to adapt to this new digital landscape. Training and upskilling become critical to ensure a smooth transition into this new era of manufacturing. In conclusion, the future may be filled with uncertainties, but one thing is clear: the future is now. We're living in an exciting time where technological advancements are transforming industries and changing the way we live and work. The adoption of Industry 4.0 and the smart factory is not without its challenges, but the potential benefits far outweigh the risks. Industry 4.0 and the smart factory represent a new era in manufacturing, and it's exciting to think about what the future holds.